Hello everyone, welcome to Pepcoding. Today we are going to solve a question named intersection node in two linked lists using Floyd cycle method. Okay, so first of all, let's go and discuss what is the intersection of two given linked lists. So let's head towards the board first. Here, let's draw the linked list first. Just suppose this is the given linked list we have. Okay, it ends somewhere here. Okay, and the second linked list start from this point. Okay, so this is the second linked list. So these two linked lists are meeting at this point. So this is called the intersection. Okay, and in this question, what we have to do, we have to find out this node. Very simple. Okay, previously we have done this question using a different method, that was difference method. In that method, what we have done, we have taken some difference of something and then we have implemented that thing to find out this node. Okay, here what we are going to do, we are going to use the Floyd method. Okay, so let's move forward and see what we are going to do. So what we are going to do here first of all, let's differentiate both the linked list by different color. Okay, let me erase this and we will make this linked list with different color. Okay, so I'm going to make this with red color. Okay, this is here. Okay, now this is the first linked list, this is the second linked list, this is head 2 and this is the head 1. Okay, so what we have to do now, we have to use one iterator and we have to place that any of these head either on h1 or on h2, and we have to iterate until we reach the tail of this given linked list. Okay, so just suppose we have used the iterator here on the h1. So now what we are going to do, we are going to use this iterator to iterate over this linked list. Okay, so it will move forward here, after that here, after that here, after that here, and after that it will be at this point, after that it will be at this point, after that it will be at this point, and after that it will be at this point where we find the tail. Okay, after reaching this point, what we will do, we will attach this with the head of the second linked list. Okay, we can start from any of the head and we have to take care of that if we started from h1, then we have to attach with h2. If we started from h2, then we have to attach this tail with h1. Okay, now as we can see, we have started from h1, we will attach this with h2. So we are here. Okay, and we will attach this with this linked list. So now it is making some cycle here. Okay, what it will do, it will make the problem same as in the Floyd, where we were solving from the starting point, where we were finding the starting point of a starting of the circle of this cycle. Okay, so this was the point. This is the same question now. Here we have a cycle and this is the starting point of that cycle. So we have done the question previously. I request you to go and watch that video first. Okay, so let's move forward and see what we are going to do. And remember one more thing, that this change that we have made here, we have to undo this change. Okay, the changes are not allowed. So whenever we get our this midpoint, this intersection point, so we have to undo this change. Okay, now let's see how we are going to move forward. We are going to use two iterator as we have discussed in that question when we were finding this starting point of this cycle. Okay, and what will happen, our fast and slow iterator will move at different pace. Fast will move at twice speed and slow will move at same speed. Okay, so now let's see. First of all, fast will start moving, that slow will start again, after that fast will move, then slow will move, again fast will move, then slow will move, after that again fast will move, and then slow will move, after that fast will move, again slow will move, after that fast will move again, and then slow will move, after that fast will move, Don't consider this as they are on the same, because slow have to move after fast, then we will consider. Then slow will move, after that fast will move with double speed, and slow will move at one speed. So here they will meet. Okay, so now what we are going to do, when they both meet, we will send the slow one again at the starting point. So this slow goes from here again at the starting point, and after this the both iterator will start moving at the same speed. So now this will also move with 1, and this will also move with 1. Again this move one step ahead, this will also move one step ahead, this will also move one step ahead, this will also move one step ahead, this will again going to move one step ahead, this is also going to move one step ahead, again this is going to move one step ahead, and again this is going to move one step ahead, and they both meet at this intersection. Okay, and we have achieved our goal. Okay, so after getting this intersection point, don't forget to remove this link. Okay, we have to remove this link after we got our this intersection point and we have achieved our answer. So now let's move forward and see what we are going to do. So now let's move forward and see how we are going to code this problem. Okay, so we are here on the editor. So first of all, we have to implement that fluid cycle. For that we have to make a function which will give us the starting point of the cycle. Okay, so let's move list node starting of cycle. Okay, inside this we have a given node name head. Okay, this is done. Now what we are going to do, when we come at this point, what we have to do, simply first of all we will check if the head is null or not. If head is equals to null, or head is equals to, actually here we have to write capital null. Yes, now move forward, either head equals to null or next of the head is equals to null. This is done. If this is happening, what we will do, we will return, oh my god, capitalist, okay, return null. Okay, this is done. After that what we have to do, we have to use two iterators, one fast and the another one is slow. So for that, let's make them first. List node fast. What fast will do, fast will also move first at the faster pace and slow will move at the slower pace. So let's move slow also first. Slow, what it will do, it will move slow. So we have both the iterator. Now let's start moving them. Okay, so what is happening here, let me tell you one thing, one case. Just suppose there is no intersection exist, how we handle that? Just suppose someone gave us these two links list. What is happening now, these two don't have any intersection. Okay, so what will happen, if we directly start finding where they meet, it will give us an error, we will reach to the null pointer. For just suppose we'll take it this head and reach at this tail and we attach this. Okay, and then we will move slow and fast, but they will never meet each other because fast will move faster and reach this null pointer. So for handling that, what we will do, we will run a loop here. We're here now. Okay, so we will run a loop until what will happen, fast is not equals to null or null, and the next of the fast is also not equals to null. Okay, until this is, we will run the loop and we will find where the both are equal. Okay, so fast will move at faster pace, so fast next, oh my god, next, and next. This will be the speed for fast. And what will be the speed for slow? It will be slow. Slow, next. This is done. Okay. Now we have to find when they both meet, we have to exit the loop. Okay. So if slow is equals to fast, what will happen? We will break this loop. Break. Okay, we come out of this loop. So there is two conditions of coming out of this loop. First is we reach to the null point, and the second is the both are equal, slow and the fast. So if the slow is not equals to fast, what we'll do, we will return the null. It means they both don't have any intersection. Okay, so I have returned null from this point. Now let's move forward. Okay, so what we are going to do now, we are going to do the case where the fast is equals to slow. For that, what we have to do, let's go on the board. When the both were at equal point, what we have done, we have sent the slow at the starting point, and again they both start moving with the same pace. Okay, so we are here. If they both are equal, now what will happen? While slow is not equals to fast, okay, what will happen? They both will move at the same pace. So slow equals to slow next, and fast equals to fast next. Okay, this is done. And before that, we have to make change here. We have to send the slow at the starting point. Don't forget that. Slow equals to head. Okay, this is done. Now let's move forward. So when we come out of this loop, it means, okay, it means they both are equal now. So we can return either slow or fast according to our desire. It doesn't matter. They both are equal now. Okay, so we can return any of them, either slow or fast. It doesn't matter. Okay, so this part is done. We have implemented the Floyd cycle method here. So now we have to handle here in this function. In this function, what we have to do, we have to first make the cycle. Okay, there is an intersection between those linked lists. We have to make them a cycle. Let's go and see how we are going to do that. Okay, here also we'll check for the null. If at a is equals to null pointer. Okay, so what we will do, for not head a only, we'll check for head b also. Head b is equals to null. Okay, this is done. If this is, we will return simply null. Return null. This is done. Now what we are going to do, look, we have to start iterating from any of the head, either from h1 or from h2, and reach to the tail to make them a cycle. Like when we reach the tail, we will attach it with the head of the another linked list, so it became a circular. So let's go and do that. So here, first of all, what we have to do, we have to make a tail. So list node tail equals to head of a. Just suppose we started from the head of a. What will happen? We will move the head tail until it reaches the last node, to the tail node. Okay, so until the tail is tail dot next is not equals to null, what will happen? We will make the tail move. Tail equals to tail dot next. Okay, so we have to use arrows here also. Yes, this is done. Now what we have to do, let's go. When we come out of this loop, it means we reached at the tail. After reaching at the tail, we have to attach it with the head of another one. Okay, so tail dot next will be equals to head of B. Okay, this is also done. And don't forget to undo the change that you have done. We are not allowed to do the changes. So tail next will be equals to null. Okay, and before undoing the changes, we will do our work. And what was the work? The work is getting the starting point of the cycle. That will be intersection also. That is our result. Okay, so we'll make a node here, node with answer name. Okay, and here we will call our function. What is the name of the function? Starting of cycle. Okay, so starting of cycle. Inside this, what will pass? We will pass head of A, because just suppose when we started from the head A and we have made this. Okay, so we will send this linked list. So head is this time. After that, we will get this starting point of the cycle. Okay, so for that, we will send the head of A to find the starting point. Okay, so we will send head of A, and the answer is stored in the answer. Now we will simply return answer from this point. Okay, so the course is all done. Whatever we have planned, we have implemented it here. Now let's just go and run this code. Before that, let me erase this. Okay, this is done. Now let's go and run this code. Okay, so it is accepted. Now let's submit this code for all the test cases. Okay, one test case is failed. Okay, let's see. So let's download the test cases. So test case input was this and -1. It means it don't have any intersection. Okay, so I think where we handled the intersection point, there we have missed something. Let's go and see. Okay, yes, exactly. We don't have to use the or, we have to use and for this. Okay, now let's submit this. Okay, 10 by 10. So I hope you have learned something. Please like and share the video and subscribe the channel. Thank you so much.